All right. I realized I have to write like this now. Maybe I can start writing left-handed. It might be more readable. Okay, so we're going to talk about something called hashing, and hashing's interesting, and we're going to do it quick and dirty because as you might be looking at the calendar right now, and you realize we have 10 days left, and well, best laid plans. We'll talk about the ideas for the end of the year. Bash, as we'll call it. So hashing. So we've been talking about how do we find values that we care about, our target values, let's say, in an array or linked list. In our bag, for example, we basically have to go through all the values and find a target value, right? And you might think that, well, organizing it as a bag's a bad idea. We might want to sort it, okay? But if we sort it every time we insert or something like that, well, that's a pain in the you-know-what too, right? Because each time we're doing some sort of moving things around and shuffling around in there. And so we have to shift things over. We have to find a place to put it in. And so there's this idea that, well, we don't want to keep the data disorganized because no matter what, then we're going to have to run through every value, okay? Especially in an array. We're talking about an array right now. And we don't want to have to keep on sorting them because that's going to be additional time each time we insert into this thing. And so hashing comes along with a solution. And think about the application for this first, which is you come into me, let's say, and say that you want to be advised. And so you give me your 700 number, I put your 700 number into the computer, and all of a sudden your record pops up, okay? And we want that to happen quickly. We want that lookup of your record and coming back to happen quick enough so that we don't have that awkward silence between me and you, right? So like 1 second or something like that, right? And hashing gives us a way to do this. So we're going to talk about a few different hashing mechanisms that allow us to jump straight to the record no matter what, okay? The first hashing mechanism we'll talk about is called direct hashing. Okay? And in direct hashing, let's say I know, what I do is every person that comes in, I give them some sort of key, okay? And I say, this person, your number is 0, and your number is 1, and your number is 2, and your number is 3, and that's the key for you. And the key is always unique, okay? Well, we can actually figure out a way, so if this person's key is 0, and this person's key is 1, and this person's key is 2, and this person's key is 3, we could actually think to ourselves and be like, well, why don't we just make their key, whatever their key has to be, the same as the index into the array, all right? So this person will put an index 0, and this person will put an index 1, and this person's record will put an index 2, and this person's record will put an index 3, okay? So direct hashing is using the key value as your index. Okay? So like if we direct hashed the people at Old Westbury, okay, so now we're talking about Old Westbury, which is the school on Long Island. What? Oh, as I point to the wrong part of my sweater. If we do hashing with the students at Old Westbury, if we did direct hashing, I think, right? So this is the 700 number, right? And we go all the way to, I think it has to be this, right? Okay, so we go from 700 to everything 70999s, okay? And all nines, right? And so we're saying to ourselves, okay, well, if we wanted to direct hash this, this is our key. This is our unique key. Our 700 number at Old Westbury is our unique key, okay? And I talked to some students, and they say that is actually what's the primary key. If so, those of you taking data structures, that is actually the primary key in the database behind the scenes. So it's very much is the key for you. There's no other key. And so we have these nice numbers that makes each person unique, and then we have something called a hash table where we keep all these records, okay? And if we're gonna directly hash, well, what we're gonna do is we're gonna put this one at index 700000000. We're not gonna use any of this, right? Because that's 0 to that number. And so that's not gonna be used because there's no one with a 700 number less than 700, right, at the beginning. And then we'll go all the way to 700 and all nines. Or something like that, okay? So, okay. So we've direct hashed and we're able to put people in there, all right? So the good things about this, you come in and you give me your 700 number, I can jump right to your record. It's right there in the array, okay? And so that's O of 1. I can jump right to your record in O of 1. If you come in and you're a new student with a 700 number, I need to insert a record in, well, that's easy too. I can just jump there with O of 1. There's no need for sorting because things are already kind of sorted, right? Because based on your 700 number. There's a few things that you need to worry about. One is that you need to know the maximum amount of this, right? Because that's going to be the highest index, all right? So that tells you how big your hashing table, and that's what we're calling this, our hash table, is going to be, okay? And so in our case with direct hashing, our hash table has to be the size, has to have basically has to be 701,000,000 in length, right? Because the highest index has to be 999,999, and we start at 0, right? So it has to be we have to have almost 701,000 million. We have to have something. I don't know. I can't do math today. But you get it, right? 701,000,000 numbers of indexes. Okay? So there's one thing. And so space-wise, it's weirdly inefficient. And this one's even more weirdly inefficient because we're not using all this space. So why do we even have that space at the beginning? I'm not entirely clear, right? Why we have that space at the beginning. And so there's kind of two things going on here. One is space concerns. And the other is, one is space concerns, and the other is, they're both kind of space concerns, but the other is we need to know the highest value we're ever going to have. Okay. And we don't always know the highest value we're ever going to have. In fact, this is pretty presumptuous. This is a very Old Westbury move, right? To be like, this is going to be the biggest number we're ever going to have, and we're never going to have a number bigger than that. Well, until we do, right? It's calling things the 700 number. Its days are numbered because I think we do have to keep track of every student that graduates. We can't just recycle 700 numbers. At least I hope we don't. Though, I wouldn't put it past us. I'm gonna get fired. All right, so let's make this better. And some of you are already thinking about it. Actually, let's go to a few questions about direct hashing, and then let's work on making it better.